Hi, 8th grade. Today we're going to be doing Natural Selection 1.6, so let's look at the warm-up. Now before we do this warm-up, you might be wondering why the warm-up is about black and white moths. They actually say peppered moths, so I'm going to explain that first. In England before the Industrial Revolution, this is the peppered moth, and the peppered moth was common throughout England, but during the Industrial Revolution, the peppered moth doesn't look so peppered anymore. It got very dark, and the reason that this happened is because during the Industrial Revolution, there was so much pollution from the factories. This was before all the polluting laws, that the trees actually were covered in basically soot. And so these moths came around a lot more than these moths. And what was the reason for that? Birds have to see and pick off moths in order to eat. So this was better camouflage during the Industrial Revolution than this. So let's look at the warm-up now. Okay, I'll read it to you. We have our two potatoes here. Okay, so I'll read this. Look at these peppered moths, Sherman. If you look closely, you can see hundreds of them. Look at that. At first I saw white moths with black specks, but look at all the black moths. They blend right in with the trees. Why do you think there are so many more black moths than white ones? I think the moths want to blend in with their environment, so they each got darker to match the trees. Actually, Sherman, there are more black moths than white ones because... So we have the one potato correcting another potato, basically. So put your answer in here. And the key for this one is, are individual moths able to adapt that quickly? Actually going to skip 2. This will be a short lesson today. And in part 3, I think we saw this example before about the newt population changing. So if I have, remember 50 years ago, before there were snakes, this is what the distribution histogram for newts looked like. They had newts with variation all the way from 1 to 10, but of course, the lower the level of poison, the more frequent that was in the histogram. But after snakes, it basically reversed. And you're going to have to make a scientific argument about this. Consider these 2 facts. Since the time when the data was collected 50 generations ago, the distribution of traits has shifted significantly. It's basically reversed. Now many more individuals have poison level 10. Since the time the data was collected 50 generations ago, snakes have become part of the newt's environment. How could these 2 facts be related? So we want to think about cause and effect relationships. And your only assignment besides the warm-up is to write this scientific argument here. So you can go with one of 3 claims, essentially. What caused the newt population to become more poisonous? So it could be that individual newts became more poisonous because they just wanted to. The second claim is the newt population became more poisonous because of something in the environment. We now know that something is snakes. The newt population became more poisonous because the snakes in this environment caused poison to be an adaptive trait in the newts. So, just a short scientific argument here. So, I would choose one of these claims. I think you're going to have a pretty good idea which one you're going with. Back it up with evidence and reasoning. And the original question is up here. Evidence, obviously, you're going to use the histograms, and reasoning, just explain why the evidence matters. And I want you to use the words adaptive trait, distribution, environment. You can skip non-adaptive trait. Population you should use. We already have the word trait. And that's pretty much it. So I look forward to your scientific arguments, and the self-assessment is optional. That basically just says, like, asking yourself, do I understand these concepts? But that's optional. So really, this lesson today is only the warm-up and the scientific argument right here. Hope that's helpful. Stay safe out there.